Good morning, everyone. Welcome to the class of C333 Environmental Engineering 2. So today we'll discuss on activated sludge process. So what is activated sludge? Activated sludge is defined as the sludge settled out of previously agitated sewage in presence of abundant oxygen. First of all, what is sludge? Sludge is when you treat sewage. For example, this is sewage. When you treat this, okay, you'll get some solid matters, okay, which are aggregated together and which has large moisture content. So this is sludge. Now, what is activated sludge? The activated sludge process is a system of biological waste treatment. So, biological waste treatment in which biologically active growth are continuously circulated and contacted with organic waste in presence of oxygen. So, what is the concept? The concept is this. Let's say this is the sewage treatment plant. Sewage treatment plant. This is your sewage coming here, okay, and sewage brings a lot of organic matter, and those organic matter are the food of microorganisms, bacteria, and algae, and microorganisms feed on them, break them down, and clean the water, and microorganisms grow in number because they are getting food. Am I right? Am I right,
Yes, sir.
guys?
Yes, sir.
So after the treatment, you'll see that there are solid getting deposited. Hmm. Now this solid contains lots of bacteria, microorganisms. So what you can do is, this is influent, this is effluent getting out. So this sludge, collect some of this sludge, okay, and because these are full of bacteria, these are full of bacteria. So collect some of this sludge and mix this with the incoming sewage so that the efficiency of the treatment of the sewage is enhanced. Why? Because you are mixing this sludge and this sludge is activated. What does it mean by activated? It means that it has lots of bacteria which will help to oxidize this organic matter. Okay, so biologically active growth, these are biologically active growth. So you are mixing it with the incoming sewage. Clear? To enhance the treatment efficiency. Did I make it clear?
Yes, sir.
So activated sludge is a system of biological waste treatment in which biologically active growth are continuously circulated and contacted with organic wastes in presence of oxygen. So this is the primary clarifier. The sewage is coming, settling tank. This is the aeration tank. This is the final clarifier. Okay, and sludge is generated. So you are bringing this sludge and some part of the sludge is returned to the incoming sewage. This is the incoming sewage. Return. And not all of the sludge are returned, some part of it is returned, and the other part is discharged for sludge treatment. Clear?
जी सर.
Okay. And this is a this process require a lot of oxygen because this happens in the presence of air. Like this is organic matter plus oxygen in the presence of microorganisms. So it becomes carbon dioxide plus water plus other stable products plus new microorganisms. So you need oxygen, continuous supply of oxygen. So aeration, okay? So you need aeration. This is the aeration tank. You can see these bubbles are the air. Like in an aquarium, you disperse air into the water. These are the bubbles, okay? These are the bubbles, is the air. You are mixing the air with the water. Requirements. Oxygen required for this process is 0.5 milligram per liter. Minimum. Minimum oxygen requirement is 0.5 milligram per liter. Then you see the bacterial growth pattern. Okay, where the bacterial growth rate is highest, guys, steep slope, this part, right? Right,
Yes,
जी
sir.
सर.
this is the number of bacteria. Nutrition requirement: nitrogen needs 10% of volatile organic matter. Phosphorus needs 1/5 of nitrogen. Guys, nitrogen, phosphorus, the food that we discharge in the or the waste that we discharge in the sewage, organic matter, right? This organic matter is what? Carbon chain, long chain, right? And they have also nitrogen. Okay, they might have phosphorus. Nitrogen is very common. Nitrogen, you know why? Because protein is what? Amino acid. Remember amino acid? Huh?
Yes, sir. Yes, sir.
So amino acid, it has carbon chain with hydrogen and nitrogen. Okay, so carbon, nitrogen, phosphorus, nitrogen. For this process to be efficient, you need 10% of nitrogen, phosphorus 1/5 of the nitrogen. That means nitrogen to phosphorus ratio should be 5/1. Okay, and then other nutrients such as potassium, calcium, magnesium, iron, etc. are required in trace amount. That means in a small amount. But majority you need nitrogen and phosphorus. Why? To keep the growth of the bacteria, keep the rate of the growth of the bacteria higher. Environmental factors. pH has to be 6.5 to 9. for normal bacterial growth. So this is the most suitable pH range for the bacterial growth. If your pH is less than 6.0, then fungi will compete with bacteria. That means bacterial growth will be reduced. If your pH is greater than 9.0, then retardation of process will take place. That means bacterial growth will be reduced. Temperature is an important factor. Increasing temperature by 10 degrees Celsius, this is degree Celsius, will double the biological activities. If your temperature is 20 degrees Celsius and if you increase it to 30 degrees Celsius, increase by 10 degrees Celsius, then your efficiency will be doubled 2 times. Bacterial growth will be 2 times. So bacterial, that means the breakdown of the organic matter, this reaction will be faster. So your purification or treatment process will also be faster. Okay, are you following me?
Yes,
Yes,
sir.
sir.
So these are the advantages and disadvantages of the activated sludge trickling filters. Advantage is more efficient method of sewage treatment because you are increasing the efficiency by recirculating the sewage. Lesser land area is required because efficiency is higher. Higher degree of treatment is achieved, great flexibility, freedom from odor or fly nuisance as the process operates under the water. Disadvantages is relatively high cost of operation and construction. Greater skilled attendance is required because you need to keep this return this sewage, and then it's more sensitive to change in quality of influent and other environmental fact conditions, and difficulty in handling large quantity of sludge produced. Design of aeration tank. That means they are talking about this aeration tank. There are lots of formula available for the design of aeration tank. Okay, so the rational method of design of aeration tank is based on the solids to be maintained in the aeration tank. Mixed liquor suspended solid. This is called mixed liquor suspended solid. Percentage of return sludge. That means how much sludge you are gonna return here. If I Are you following me, guys?
Yes, sir.
Ji, sir. Ji, sir.
Yes, sir.
So let's say this is 100% sludge here. You are returning 40% sludge here and 60% sludge here. So how much you have returned? 40%. Okay. So that's what they're mentioning, that percentage of return sludge, where SVI equals to sludge volume index, which is volume of activated sludge in milliliter for 1 gram of dye sludge. Volume of sludge after settling into 1000 divided by mixed liquor suspended solid. So these three are the same thing. Volume of activated sludge in 1 milliliter for 1 gram of dry sludge. That means volume SVI is actually the volume of the sludge how much sludge? That much of sludge which will have a weight of 1 gram when it is dry. That's it. And this volume is in milliliter. That's it. And P is the percentage. Okay. Here they're telling that here design aeration tank to treat 6.8 million liter per day of sewage. Okay, 6.8 million liter per day of sewage. This is basically Q. Having BOD of 200 milligram per liter. If the mixed liquor suspended solid is to be maintained as this. So this is given, and this is 2500 milligram per liter. And the BOD loading is 40 grams per 100 grams of suspended solid. Okay.
Yes,
So
sir.
we know that load equals to what? Load equals to actually L into Q. Remember this? Concentration into Q. So BOD load here, then you'll get it in mass per unit time. Weight in mass per unit time. If you multiply L with Q, unit will be this. So anyway, so let's see L. L is what? L is 200 milligram per liter. So 200 milligram per liter. And Q is what? Q is 6.8 million liter. So this is million liter per day. This is milligram per liter. So this will be milligram per liter. Okay. Wait a minute. This is million liter per day. So this is liter per day. And this is milligram per liter, right? So this cancels out. So this will be milligram per day. This is not milligram per liter, no? Milligram per day, gram per day. Okay, clear?
Yes, sir.
Now solid content of mixed liquor is a mixed liquor suspended solid. So suspended solid is a solid, guys, right? And that is 2500. So solid content is 2500 milligram per liter or 2.5 gram per liter. Design BOD load is 40 grams per 100 gram of suspended solid. So 40 grams of BOD in 100 gram of solid. So design BOD load per liter is actually this multiplied by this. Simple. This is simple, right? Right. Um, think like this, that 100 gram solid contains 40 gram BOD. It's given that 100 gram solid contains 40 grams BOD. Okay.
Yes, sir.
Then your question is, okay, then what is the rest of this 60 gram solid? That may be sand particle. That is not BOD. Is sand particle BOD, guys? Is sand particle BOD?
So one.
I'm asking you, is sand particle a BOD? BOD is what? BOD is the organic matter. BOD is the organic matter, biodegradable organic matter. Okay. So is sand a biodegradable organic matter?
No, sir. No,
No.
sir.
So in this 100 gram sand, sorry, solid, and this solid can be sand, this solid can be BOD, this solid can be plastic. We don't know. So among this 100 gram solid, you have 40 gram BOD, and rest of the 60 is something else. Okay. Okay. Now, 1 gram solid contains 40 by 100 gram BOD. Fine. Now, 2.5 gram solid contains how much? 40 by 100 into 2.5. Am I right?
Ji
Yes,
sir.
sir.
So if you do this, you'll get
One sir.
1
Sir.
the gram BOD per liter of water. Okay. Volume of the detention tank is what? Look at this. Rho equals to m by v, right? Huh?
Yes, sir.
Yes, sir.
So v volume equals to m by rho. Fine. This m is actually the weight W. What is the W, guys? We got it. BOD load W is this. Write it down. 1360123. What is the rho, guys? We just determined this. 1 gram per liter.
Yes, sir.
This is the rho. This is, so this is in gram per day, and this is in gram per liter. So this will be in gram cancels out liter per day. Let's don't write day explicitly. So this is actually this liter. This is the volume of the detention tank required. From liter, if you divide it by 1000, you'll get it in meter cube. That's it. This is one. Okay. Return sludge is 35%. Here, return sludge is not 40, it's 35%. Now, so this will be 40%, right? So this will be right around. Okay, are we returning sludge to anywhere? No, we are not returning sludge to anywhere. So this will be 65%. Together it is 100%. Okay. Now return sludge is 35%. So volume of the tank, guys, you are returning sludge. Remember, you are returning sludge. So volume required will be higher. Am I right? Hello.
Yes, sir.
Yes, sir.
You know what? Let me tell you again. Um, you are trying to determine the volume of this tank. Volume. If you don't return the sludge, then this Q is coming here, Q. So the volume requirement will come from this Q. But now you are returning the sludge. So this Q and this is 35%, right? Of this Q. So together, this is 0.35 into Q. Together, this QT will be Q plus 0.35 into Q. Am I right?
Yes, sir.
That means 1.35 into Q. So your volume now will be this. So volume of the tank will be this volume multiplied by 1.35 because you are returning 35% of the sludge. So this detention time, oh, it's easy. Volume equals to Q by time. So T equals to Q by V. T equals to Q by volume. I wrote it wrong. Why don't you tell me, right? Sorry.
স্যার তাকায় ছিলাম স্যার মানে বুঝতেছিলাম না যে আসলে কিউ ভি
Uh,
বাই কিউ নাকি
yeah, I did a mistake. Okay, so Q equals to volume by time, right? Okay,
জি স্যার
so T equals to volume by Q. So this is volume, this is Q. So you know the volume is 18.36 and Q is what? Q is actually, it's actually given 6.8 million liter per day. By the way, this is in meter cube and this is 6.8 million liter. So if you convert it to meter cube, you have to divide it by 1000. So it will become 6.8 into 10 to the power 3 meter cube. Am I right? From liter to
Yes, sir.
meter cube.
জি স্যার
So 6.8 into 10 to the power 3 meter cube. This is also in meter cube. Meter cube. So you have per day here also, right? Per day. So this day will come here. Clear?
Yes, sir.
জি স্যার
Okay. So well, we will do the finish. We have only two problems, so we have next class, so we can solve it in the next class, inshallah. Okay. Any question, guys? No question.
No,
Okay,
sir.
নো
then
স্যার
thank you. Thank you very much. Have a good one and stay safe.